Great. So you're looking at the portal. The steps that I'm about to go through and take you through, you can get to yourself. It's all in the DP0.1.lsst.io. So you can get to the set of instructions that I'm about to just go through for you in the DP0.1.lsst.io documentation and resources. So we're going to basically be doing this tutorial right here as we go through step by step. So when you arrive at the portal, you see this, many windows, many options. The first one is to select a tap service, but always leave this one at the default. So you can see my mouse here, always leave that to say at the default here. And then the second one, you can select your query type. Today we're doing a single table query, but if you know what ADQL is and you prefer that instead, you can do your queries that way. We also have some advanced tutorials and we'll cover that in future delegate assemblies, how to do that kind of query. Here under select table, you're always going to want to be working with the DP0.1 DC2 catalogs. That is the data catalogs for you for DP0. And then over here, if you click on this down arrow for the tables that are available for this collection, you'll see there's actually 5 different tables, the object and truth match tables. And then there's also a position, a reference, and a forced photometry table. And you can choose from those different tables. Future tutorials that we will have, we'll use these other tables, but for today, just to give you a portal demo, we're just using the object table. So these are going to be all objects that are detected in the 5-year coads in the DC2 data set. So these are all objects that are detected in coads. So not variable sources, we're just talking stars and galaxies here.
Excuse me, I only see 3 possible tables: TAP, Scheme, UWS, and the DP01 DC2 catalogs.
Roseanne, are you looking in number 3, select table?
I think so, yeah.
Yeah,
there's a down button there.
Yeah, there are 2 menus there. They're next to each other, left and right. The left-hand one is entitled Table Collection, and there you want to just choose DP01 DC2 catalogs, and that's really what you should always choose there. And then the actual tables are in the menu on the right.
Oh, I see. Okay. Yes. Thank you.
Okay. Good, we got that sorted. Yes, so we'll be using DP01_DC2_ catalogs, and then from that set, we choose the object catalog. Okay. So the next thing that you have here in the portal are the constraints for your query. We're going to be doing a spatial query today, which is also the default that appears. The longitude column and latitude column are preset for you. It selects them from the table that you've chosen. So those are already there as the RA and DEC. And then here under coordinates, I'm going to put in about the center coordinates for the DC2 data set, which is 62 and minus 37. For that, I'm going to do a spatial query. I want like a 1 degree radius circle at that locations. So I put that location in, and then now we have a box here for the radius. I want to use degrees. I want to use 1 degree for the radius. So that kind of sets up where our spatial query is going to be. And then over here on the right, we have our table view. And you can see that there's some columns of this table that have been pre-selected for you. And you can see their column names here. Then there's some other information about the columns. The other one you'll probably be most interested in is the description of the column that tells you what is the data in that column. In order to see all of the pre-selected columns, or in other words, in order to filter this table on only the selected columns, because you can see here it's showing some lots of other columns. And if you scroll down, there's lots of columns that are not selected, many. Some of our tables have hundreds of columns, but to see just the ones that are pre-selected, use the filter icon that's right here at the top of the column of blue check marks. And if you filter to just the columns that are pre-selected, now you have a shorter list, and that's just the pre-selected columns that we think are going to be most useful for most people most of the time, basically. And so within these, maybe I don't actually want all of these columns. So you can choose to, for example, if I'm not going to use the fluxes that I query, I can deselect them so that my query won't spend time returning those fluxes to me. And then maybe I'm not going to use any of the signal to noise ratios either. So I'm going to remove those ones from my filter, from my selected columns. You can do the other way around and you can add extra columns that you want as well, of course. And then I just click on the funnel again. And so now I'm just looking at the columns that I want to return. And so maybe I don't want everything that's in this radius 1 circle. Maybe I just want the good, bright things that are in this 1 radius circle. And I can do that by setting some constraints in this column right here. So if I just want the good sort of extended, I think that one should be 0. Yeah. So if I just want things that have been cleaned out, so there's no artifacts, just good detections. Set clean equal to 1, good equal to 1. And if I just want stars, so things that are not extended, set extended equal to 0. And then if I just want bright things, I can say only return things that are magnitude less than 24 in all magnitudes. They'll just return to me bright things. And if I want a small, 50,000 is a totally fine number to use for a regular query. But if you do want to change the row limit, right, so I've come down here to the bottom and I can change my row limit to 10,000 instead. So that's how I set up a query. I use the spatial constraints over here. I select the columns that I want returned, and I can put some constraints on the columns to get the data that I want, and then I can set a row limit. So before I go ahead and click the search button, which you should feel free to please go ahead and do, I'm just going to see if anybody encounter.
Can you review the constraints that you put in the list again, please?
Can I review the constraints that I put in the list like this?
Like extended is equals 0 and then the magnitudes. Did you do anything else?
Just those.
Okay, thank you.
Yeah, those are the only constraints that I put in.
Mm-hmm.
I missed about the 50,000 limit. Were we supposed to put that anywhere?
So if 50,000 is totally fine number of objects to use as a default. If you do want to change your row limit, I just wanted to point out that it's down at the bottom.
At the very bottom, there's a,
Can you see the bottom of
I
the screen?
it's
There's something called tracked. I and see row limit.
Oh, now I see it. It's very small. Yeah, bottom left.
is it on this table or is it off of the
Oh,
table?
not in the table, bottom left of your page.
Oh, I see it. Yes, I see it. I see it. Yes. Thank you.
Oh, okay. Oh, I see. Row limit. Yes, got it. Got it. Yeah.
Okay, cool. And let me just, please unmute and raise an issue before I hit search. If you check the columns and you want to reselect the defaults, if I remove the filter, it just goes back to showing me both selected and unselected columns, but it doesn't actually change your selected columns. So I can put the funnel filter back on, but choosing reset column selections and constraints is the way to get yourself back to 0. And if you really want to just refresh the whole query, you can refresh your page. You can do a Control-R or whatever it is to refresh your browser, and it'll get you back to the start.
Lisa, how is there a dictionary for the columns so that one could see what are values that one could select?
Yes, there's, we don't quite do the values, but what you're looking for is basically the data products definitions document.
Yeah.
So let me show you main page of dp0-1.lsst.io. This is where all the information is. The DPDD you can get to from the main page. And then it tells you about the images, but we're working with catalogs today. So this is where you would come and look at the schema and learn more about the columns.
Mhm.
Is here in the DPDD.
Thank you.
Yes, that's a good question. Thanks. Okay. Okay, I'm going to go ahead and execute this search. The search button is in the lower left. It's going to think about it for a second. And then it's going to come up with the results of your search. And the first thing I want to point out is that the image that's going to display at upper left is not a DC2 image. There is no image access via the portal. So this image that pops up, I mean, it's a little bit useful to see the spatial results of your search, but really it's not appropriate for DC2. So I don't even want to really look at that. And I can make this go away and I can look only at the plot where the default plot that shows up is RA versus DEC. That's just the default that you're going to get. If I just want a view that has just the plot and just my table, up here at upper right, you can see there's a couple of selections for your view. And I can choose just XY dash table. And now it takes that image away because we don't need it anyway. And you can choose to have like all three or just any two of these image views here available. Some people got no data. It's DEC minus 37, not plus 37. Okay, I'm going to go ahead and I'm just going to make the plot because we're pretty much just one step away from the end of the tutorial, and then we're going to deal with everyone's questions and issues. So if you, a lot of people got no data. Yours might look different because it would be a different 10,000 random results. Works for some people, but not for others. It should just work for everyone. So I'm just going to go back. Here's what my search looked like. So if you didn't get any data, you have a chance now to just double check all these things that I did. So check that you have the exact same RA and DEC coordinates, exact same one. Make sure this says degrees, not arc seconds. Yeah, there is a funky thing where if I change this, it stays the same, right? It has changed. So if I think when we arrived, the default might have been 10 arc seconds.
Yes, that's the default.
And if we changed it to degrees first, you would have been searching on the, if you didn't notice that it changed here.
I found that I had to actually put in 1 degree if I wanted 1 degree.
Yes, yes, you would have. Yeah. Okay, so it looks like, yes, great. Looks like that was actually the little piece that most people missed. So let's go back to our search results. Oh, Will, do you want to speak the question?
Yeah, if you don't mind. In the selection box, if you have a selection criterion, but the checkbox is not activated, does that mean the criterion still gets applied?
Yes. Yeah. The checkboxes tell you which, I mean, if you know SQL, the checkboxes can tell you which columns are in the select statement, and the constraints tell you which ones are in the where statement. And there's no requirement that something be in the select in order to be used in the where. So yes, you can put constraints on columns that you don't return in the query result.
I'm asking because some of my unchecked rows here have less than 24, which I don't think is right. And I'm wondering if that's why I'm getting no data.
I mean, we could probably determine in any particular case, you know, why you're getting no data. Maybe there's you know something that's been entered slightly differently. I'd be happy to work with you maybe offline if you want to send me a private message through Zoom, and I can try to
So I'm
give you
having
some
the same
additional support.
issue. I'm having the same issue as Will in that I put less than -24 in the mag -G, and it keeps populating up by other columns by RA and DEC less than -4, and then I delete it and I scroll back down to make sure all the columns are okay, and I scroll back up again and there's this random less than 24 in other
I had the
columns
same
as
problem.
well.
Yeah, I think you are running into an actual bug there. Unfortunately, that's that may just have appeared. So if you, I don't know what to say. It's there is a workaround, but it's a little strange. If you select, I don't know. I don't necessarily want to teach you a workaround that you won't need for very much longer. But if the problem happens when you apply a constraint, when you're scrolled down past the first page in that table, like if you scroll in the table, and then you enter a constraint, there seems to be a problem in which column it gets attributed to. So you have to scroll down like by an entire page. So it's particularly if you've been putting these constraints on without filtering first, when the table is much longer, that's when this seems to get triggered. That I don't think like really experimenting with this in real time is going to be very enlightening. So
Okay.
maybe perhaps this is something where we should.
Oh, it did happen.
Yeah, there we go.
Yeah.
Yep, that's that. I noticed that yesterday for the first time.
Okay.
Well, thank you very much for clarifying, Greg. That I think is what we're seeing.
Yeah, I just discovered that yesterday, and I already filed a ticket for getting a fix to that behavior.
Perfect timing the day before demo, isn't it?
Yes, it's awful. But so one thing I would say, maybe just to help you with this, if you need to do a kind of a cleanup on your query, when Melissa's done with the current query, maybe I can lead you through one thing that you can do. If you, Melissa, do you want to concentrate on showing how to make the plot first,
Yeah,
and then we can
it's
go
a
back
known
and
issue. We are like kind of well behind now. So
yeah. So why don't we just do the making the plot, and then maybe we can use some breakout time. I can give a little bit more support on this. How about that?
yes, that'd be great. Yeah. Especially since it's a known issue, it's going to go away.
Yeah.
Thank you.
Yeah. And thanks, Will, because it's not something that I had encountered because of the way I did it. So good to bring that forward. So now I want to come back to here, and you don't want a plot of RA versus DEC. So you want a color magnitude diagram instead. I'm going to show you how to do that. And what I did is up here at the top right corner of the plot window, I clicked on the double gears icon, which gets you all the settings for the plot that you're making.
Sorry, Melissa, to interrupt. Quick question. There was this green, there was two panels initially. There was on the left, there's a bunch of green sources. And how did you remove?
It's at the upper right. You can choose
Okay.
any two of the panels to show. And it's just X, Y, and table that will be
All right, thank you.
useful. Yeah. And then double gears, and we've got all of our chart options. So right now you can see the X and the Y are the RA and the DEC, but let's change that instead and use some of the magnitudes. So we'll do R minus I for the X-axis, and then you can do G for the Y-axis, and give your axes a label under chart options. That X label, color, we're using R minus I. And for the mag, we're using G. It's a magnitude, so let's reverse that and click a little
Mhm.
reverse under there.
Mhm.
And then once you have your x-axis defined, your y-axis defined, label your axes and choose reverse for any magnitude.
Mhm.
Clicking apply will give you a new plot.
Mhm. So you have to put in for X and Y something that comes directly from the table for the name of it. Like you said, R minus I. So I just wrote in R minus I, but that wouldn't work, would it?
No, that's going to give you an error, and it's going to tell you right away that those aren't columns
Okay.
by highlighting it red. But as soon as you
Okay.
start typing, it does
Mhm.
give you options.
Oh, okay. Yes, yes, very good.
And there, you have made a plot in the portal. And that's as far as I wanted to get people today. It's just doing a search, making a plot. In future sessions, we'll go into more detail on how to do more advanced queries, including like table joins and things like that. So I do want to move on to the notebook aspect now to get you through the first
Can
notebook.
I ask one very quick question?
Uh-huh.
Suppose I see my plot and I feel like I should have selected more than 50,000 to sample from. Is that easy? Do I have to go all the way back and restart from the start? Or if I'm in here, can I add more stuff to the plot?
I think it is easy just to, so I'm going up to the RSP tap search button at the upper corner, and it will take you back to your original search. Everything will still be set up. And then all you'd have to do is change the row limit. I think that's the fastest way.
Okay, perfect. And it remembers then what I was plotting because you changed the plot.
I don't think it remembers your plot though, actually. So if I
okay.
did the search, it comes back up with the defaults. So you would have to reset your plots.
Okay,
If you want to save your plot, what would you do?
I can speak. I can speak to that. So you can save the table as data with the little diskette icon there, and you have a choice of a number of different formats, including CSV.
Oh, excellent.
For that. And you give it a file name, and then it will come back to you as a downloaded file. So then from the image thing, if you click on the save icon, you will just get a graphic bitmap image of the plot that comes back. And depending on your browser settings, that will either get be handled as a download in your browser, or it may get opened automatically, like in Melissa's settings. Evidently she has downloads open immediately, so it's just handled as a browser download at that point.
So how did you make that bitmap image? Sorry.
The little diskette icon in the toolbar for the image for the plot. Melissa's kind of pointing her cursor at it there.
And it just downloaded straight away.
Right. And one very quick question: of all the things we can look for, can we are the tables that are available, do they include things like globular clusters and galaxies, or do we have to do a cross match with known coordinates?
So this is an entirely simulated universe. So there are no known coordinates. This is that's why the sky image is not useful. Because the background sky image is from the real universe.
I thought we were using a real data set, though. Isn't there one real?
No, this is an entirely simulated
it's
data set. It is the universe is simulated, and the telescope's observations in that universe are simulated.
I see. And have they included things in their simulation, like saying, well, I'm going to put in some globular clusters, or?
I'd have to defer to someone else to describe exactly what went into the simulation. That was the Dark Energy Science Collaboration's simulation effort that's represented here.
Right.
I believe clearly there are both galactic and extragalactic components. There are stars and galaxies, and I know there are supernovae in the data set. But beyond that, I don't know what kinds of astrophysical objects are there. I think there's a whole paper on what's in the simulation though,
I
that
think
you
probably
can
Wendy
find from
needs
the
to read the
documentation.
paper, right?
Yeah.
Thank you. I
Yeah.
don't want to take up much time with this because I know Melissa needs to go on.
Multiple papers and the data products definitions document that we. Yeah. Okay, so I see there's a couple more questions and we will take them, but get yourself over to the notebook aspect as I'm wrapping up the last couple of questions. I think, Panda, did you just have your hand up?
Yes, Melissa, thank you. I just wanted to point out, you commented that the data set is at random. So I was wondering if I need to set some kind of a random seed if I want to repeat the analysis some way. Or
no, it's it was all chosen, long ago, right? This data was generated a couple of years ago, and you're not getting new data each time. It's a fixed data set.
Thanks.
So a quick question in terms of overplotting things, if we want to overplot something or draw lines on the plot, is there an option to do that?
I think we should probably take that to a breakout because as Melissa reminded us, we're a little behind on demonstrating the notebook side of things. The short answer is yes, you can overplot, and we can talk about that in a breakout.
Yeah. I really just designed this first one to be like super simple. So yes, thanks, Gregory. Yes, there are, and we'll come back and do more portal demos in the future as well to build you up. But I do need to get people using the notebooks now because I know we have a lot of new notebook users. So I would like to see a couple confirmations that people have their notebook aspect servers spun up and they're looking at the first tutorial notebook, getting some yeses. Okay, great. So it sounds like people's servers are spun up. When you first log in, it probably looks like this page. So if this is like your first time coming to the Jupyter Lab aspect, you probably see this when you first log in. And what we're asking you to do is go to the notebooks directory. So here over at the left, you have a directory browser. Go into your notebooks directory. There will be a tutorial notebooks directory also in there. And you go into that one. And then double click on the first notebook, 01 Intro to DP0 Notebooks, IPyNB in your directory structure, and it will open the first notebook for you. So that's the sequence of events to go from server started and the launcher page to the first notebook. So if you had trouble getting to that stage, do post in the chat and the people or the Rubin staff who are online will help you out. And I'm going to start going through the first notebook. So this is what you see when you arrive in the first notebook. There is no table of contents, but the first thing that we tell you about is that over here in the leftmost column, if you click on the what's called a little hamburger icon of the 3 vertical lines, you can get a table of a table of contents for what's in this notebook right here. And that's this little icon. And then if you go back to the file folder icon, you're back in your file structure directory like this. So over here on the left, you have some navigation powers, even while you're still working in a Jupyter Notebook. So Jupyter Notebooks are basically combinations of text and executable code. Each of these text or blocks of executable code is in what's called a cell. And so here you can see an example of a code cell that's just going to print hello world. But all of the text that you see is also in a cell, just a different kind of cell. And in particular, this text was generated from a Markdown cell. And if you double click on these words, you can see the cell that created that text. And you know that this particular cell is Markdown because up at the top, in your top menu bar for this notebook, you can see the cell type is Markdown. So this is why if you happen to double click sort of randomly somewhere in your notebook, you might see this cell pop up with the Markdown code that's making the nicely formatted text for you in the notebook. And from any cell, so right now you can see my cursor is next to the little happy face in this cell. To execute either a Markdown or a code cell, you press Shift Return. and it executes it. When it's a markdown cell, that execution means it goes to nicely formatted text. And in the case of our first real code cell here, having my cursor be in the cell, right here, it's right at the end of this code statement to print hello world. And I press shift return, and it executes that piece of code. So it is printed hello world to the screen. So that is what a cell is in a notebook, and you execute a cell by pressing shift return. That's sort of notebook 101. Yes, it's important as you use Jupyter Notebooks to execute the code cells in the order that they appear, because they are doing things in sequential order. If you ever find yourself in trouble in the future, you've written some piece of code that's taking way too long, or it's intended to be a search that takes a long time, but while it's executing, you notice an error in the code, and for any reason you want to stop your cell from executing, want to draw your attention to the top menu bar, the file, edit, view, run, kernel, etc. menu bar up at the top. And if you click on kernel, you have a couple of options to, for example, interrupt kernel or restart kernel. And that means it stops all the code that is currently executing in your Jupyter Notebook. So it's like an emergency stop button. If you've sort of been executing things and then you want to go back to a fully fresh notebook with no code executed, no outputs shown, that's the restart kernel and clear all outputs selection. So that's a couple of notebook basics just to help you out with executing. It is safe to interrupt the kernel. Yeah, that's a completely safe thing to do at any time. You'll just have to restart it after you do interrupt it. And so, yeah, that's a safe thing to do for any reason. Thank you, Yanni. Yes. So that's how to execute code in a notebook, how to stop it if you get into trouble. If you're not familiar with Python, this notebook does try to tell you a little bit about why we use Python packages and what they are. So for example, here we're importing two very common Python packages that are used for math and for plotting. And so I do a shift enter in this cell where I'm importing NumPy and matplotlib, and it prints the versions of these packages that I've just imported for you. This cell, so these kinds of import cells are usually mandatory. You have to import the packages that you're going to use. This part of the notebook gives you a lot of other information about packages, how to see what's in the package, how to see the functionality available, how to get the help for a given package. I'm going to leave all of these commented out, but they're there for you if you're new to Python, sort of go through and do a little bit of testing about Python packages. And then this is a cell that you will see in many notebooks, and they're telling you what version of the LSSD science pipelines you are currently using in your server, which can be important if you're doing sort of more advanced code development. But if you're just here to test out things, probably isn't going to matter. So let's start and do a catalog query. For the notebooks, it's the same backend service. It's the same backend tap service that we used in the portal. You just get to it from a different way. So we're going to be using TAP, which stands for Table Access Protocol, from this notebook. And the first thing we're doing here is, again, we're importing a couple of common packages that we use. This one is sort of, Pandas is a generic catalog package for dealing with large catalogs. And then this is the one that's—
Thank you, you too.
Oh, Will, you unmuted.
Sorry.
That's okay. And then there's one that is a specific piece of LSST software that's going to set up your TAP service. And so we do shift enter in that cell. And this is a little error that comes up that's fine to ignore. It's not even a real error, it's just a little warning. So this here has got your TAP service started up. This next part of the notebook tells you a little bit more about how to use the TAP service to explore what's available to you. Because right now, maybe you don't know what the tables are that you can get to from TAP. By uncommenting some of these columns, and I'll just do the first one as an example. You can get just the schema. So if you're not sure what your search is that you want to do, you can get just the lists of the catalogs that are available, lists of the schema for those catalogs, like which columns are available in the different catalogs. And you can use these commands to sort of probe or search through the catalogs that are available to you. They're all commented out because they're just sort of optional things for you to use to learn about the TAP service. But I uncommented these rows in this cell here. And now I'll do a shift enter just to show you what happens if we just want to get the names and the descriptions of the tables that are available just from the schema. So this is not returning data, just returning like the table schema for you to view, which can be really handy as you're just setting out and just learning about what's available. And so you can see this is returned some of the table names, and these are the same tables that we saw in the portal because it's the same service, the TAP service, and then descriptions of the tables, which we had seen before as well. So this is these are ways to get exploring with what you can access through the TAP. And then we're going to skip ahead a little bit and say that now we've identified the catalog that we want and also the columns in that catalog, and we are ready to retrieve some real data from that catalog. And then this is an example of a search that you might want to do that's a little bit similar to the search that we just did in the portal. In this case, we're only asking for 5 columns to be returned, the RA deck and the G and R and I band magnitudes. We're asking to get those columns from the object catalog, same catalog that we just used via the portal. And we're asking to only return them within a radius near the center coordinates of the DC2 region. So we're using a contains statement here, where we're saying that any point that is returned should be contained within a circle with a center of 62 minus 37, just like before. And this time though, we're using a radius of ½ degree for our search. And so we're implying this condition, imposing this condition on our search where this contains must be true equal to 1. And then we're saying, okay, and just give us 10 example rows from this search in this case. So we've kind of set this up. It's the same search that we did in the portal, or very similar, except we're using the TAP service that we defined in order to get it. And then the results that come out of this TAP service, we are using the .to table in this case to define our results table. And that just makes them display nicer. It's actually an AstroPy table that makes them display nicer. So a shift enter, now that we're ready, you can see the 10 records that we returned from this particular search, this particular little demo search using TAP in the notebook. So I want to sort of take it up a notch and do something a little more complicated. So now we've defined a results search that's a little more detailed. We're returning a few extra columns. We want the magnitude error in addition to the magnitudes. We're using the same or a similar spatial constraint, except now we're going up to 1 degree radius like we did in the portal. And then a couple of the similar constraints on the good, clean, and extendedness parameters for the objects. And instead of constraints on the magnitudes themselves, we're putting constraints on the magnitude errors. So not exactly the same as the portal, a little different just to show you. And then again, asking for 10,000 rows. So now we can do shift enter and it'll execute this query on the object catalog. And this time we're taking the results that we got, putting them in an AstroPy table, and then converting that to a pandas table, which is just a Python package that is really useful for dealing with large catalogs of data. This particular notebook gives you a couple of examples of how to use pandas tables if you're not familiar. We will let you explore those on your own at another time. And then when it comes time, now that we want to make a plot like we did in the portal, we want to plot, here we're using the matplotlib package that we imported earlier. And we're plotting here R minus I as the X and the G as the Y with a couple of other statements here to control the plotting size, and doing a shift enter will get us a similar looking plot as what we had before, except in this case, it's a little different because we didn't apply the magnitude 24 cutoff. So you can compare sort of
I
this.
got some kind of error when I did the shift enter, trace back something.
You got an error out of the plot. You did have to execute all the other same cells as I did on your way down.
Oh, okay. Okay, thanks.
Yeah. And also in the case of this, where it's just where it's a tutorial, you could go up to the top. You could do a restart and clear all inputs, get back to fresh. And you could do a restart and run all cells, and it'll just do everything for you so that you'll get the exact same results as what I'm showing. So a restart and run all cells will probably help fix the error you're reporting. So that's the sort of the first half of this notebook, is to get you to a color magnitude diagram that's sort of similar to the one that we made in the portal. And I'm just going to swiftly move on and show you image access. And in this case, we're not using the TAP service. The TAP is just for accessing catalog data for DP0. In the case of image access, you're going to be using some LSST software that's called the Butler. And what the Butler does for you is it lets you retrieve images without knowing exactly where they are stored on disk. So you retrieve an image by its qualities, basically. And you can retrieve it and show it without knowing like the exact file path to it, for example. So this all tells you much more about the Butler itself. It's a package that we have to import. So we're doing shift enter in this cell. The way that Butler is organized into repositories and collections of data, this statement will always be the same for all of your image access for a DP0. So we do a shift enter here to define our repo and collection. And then in the next cell, we do it again. We're defining an instance of the Butler for this repo and this collection that we want. And it'll probably give you this little confirmation in pink here that you're set up and ready to go. And so now in this case, we're kind of using an example where we already know the central coordinates of the image that we want to retrieve. So in this case, we're saying like, if the example is, say your friend Jeff told you that there's a really cool looking DC2 galaxy cluster at a certain coordinates, and now you want to go take a look for yourself. So in decimal degrees, those coordinates are 55.7 minus 32.2. So here we're going to use the LSST geometry package to define a point on the sphere that is right at the coordinates that you're interested in. And then we use this little bit of code, which the notebook describes in more detail, to figure out which tract and patch those coordinates are on. So the entire sort of LSST data, the big co-added all sky, in this case 300 square degrees image, is divided into large tracts and then smaller patches, where a single patch I think matches about the size of a CCD. So a patch is like a manageable piece of an image that you would conceivably want to get and use. And tracts and patches are numbered. And so we use this little set of code to go from a coordinate on the sky to knowing which tract and patch in the LSST sky map that our coordinates lie. And that's the tract and patch ID that we use to retrieve that particular image from the deep coad. So that's what we're doing here. So we're getting that tract and patch for the coordinates that we want. And we define a data ID with the tract and patch for our coordinates. And in this case, we're also specifying that we want the I-band image for that tract and patch, which you do have to do. And then we are using the butler.get statement to retrieve the deep coad image for that data ID. So it's multiple steps to go through from coordinate to getting the image that you want, but not too bad. So letting that cell run, you see the little asterisk, the little star is there until it runs. And this was an incredibly brief intro to the Butler. Tutorial notebook number 4 goes much further into depth in using the Butler. And also the 4th delegate assembly will also go into much more depth. And we can have a breakout session about the Butler after this as well. Now that we have our image, our My Deep Coad is the name of our image. We want to display it. Here we're using a tool called AFW display to display the image. So first we will import it, and then we use these set of commands to display the image. And this is very brief, but the 3rd tutorial notebook goes into much more detail about how to use AFW display and how to display images and how to deal with them and work with their features and stuff like that. So that takes us just 2 minutes over the first hour, but gets you through a tab query and an image retrieval and display in the first notebook, which is what we wanted to make sure that you had the tools to do from at least day 1. So, okay, I'm going to pause now and turn to the questions. Feel free to unmute while I check out the chat.
So are there any regions of the sky that haven't been simulated? I mean, what should we be avoiding? Or should we just use the patches that you've defined here to test things out?
Yes, the DC2 data set is 300 square degrees of the sky. So there's lots that have not been simulated. It's a relatively small area of sky compared to the future LSST. So you want to be looking at the at our data products definitions document and also the LSST desks papers about the simulated sky survey to understand which coordinates are included. Oh, if you did select coordinates that happen to be at the edge, and even you can kind of see it here, our galaxy cluster is in the lower right corner. So there are other ways to do cutouts that are centered on your object of interest. This is one way just to really quickly grab an image that contains your object, but to make a cutout that's centered on your object. I think that is in notebook number 4. I think we provided some tutorial about doing that there. So if your object is at the edge of the patch and you want a nice picture that centers it, you can do a cutout. Are there any preferred browsers? Oh, no. I mean, any modern browser I think will work. If you are seeing errors with a certain browser, that sounds like a GitHub issue.
I mean, we certainly want to hear of anything that appears to be a browser compatibility problem. And all of you collectively have, much more capability of running into odd corners of the space than we do in our own testing. So that would be very interesting to us if you found an issue. I can't guarantee that it would be fixable, but we'll certainly do our best.
Cool. Yeah.
So Melissa, one thing that came up in the chat that maybe is worth reiterating to folks who are new to Jupyter notebooks is that, for example, you pointed out that you can just say run all the cells, and then it's just like I wrote some code and it's going to run everything. But then when you were stepping through it, you were executing each cell on its own, and so it's worth noting to people that. One sort of hazard of Jupyter notebooks is that now, say, Melissa just made this plot, you can go back up and execute earlier cells in a sort of a non-sequential order. And so that can sometimes mess you up. And so this restarting the kernel, when you get things out of order and things are not cooperating, restarting the kernel and just starting again from the beginning is a sort of clean way of getting out of that.
Yeah. Yeah, that's a good point. And it's something that I definitely ran into issues with when I started using Jupyter Notebooks. As you're trying to like develop code, yeah, go back and do the restart periodically. So I'll do that now. You'll see it's just cleaned up the whole notebook. Is it possible to run processes in a terminal? Yes, we haven't really gone over any use of a terminal for running command line. And most of our tutorials deal with using things via notebooks instead of the command line, but it is possible to run processes from a terminal and to access any of the science pipelines from there. You probably want to do this first. Oh, yes. Yeah, it's a terminal. It's in the notebook aspect, but it's command line interface. So
there's no reason to imagine that something that was run in a terminal would somehow be more durable than in a notebook. In particular, I think that the motivation that that Natasha expressed is not that's not going to address that concern.
Right, I see. Yeah, if it's going to time out, it's going to do it no matter which service you use.
Yeah, sorry, I just put that in the chat. So the kind of notebook service, whether you're using the notebook or the terminal. Oh, by the way, hi, this is Frossie, and I'm in a hotel, so sorry for just speaking. So the kind of notebook and including its terminal service are predominantly oriented towards the user interactive analysis. For Rubin operations, the way that users will be running long-running processes, very data-intensive processes that take a long time or deal with a lot of data, will be through a user batch service that is not yet available to you in data preview. So the eventual plan here is that notebooks will be fairly transient. Right now, we're not actually imposing any limits, but they will not, we'll not be able to run like a 1 month long job in a notebook. At some point, your notebook will be terminated in order to encourage use of the user batch system, which is going to be much more efficient. So for now, go ahead and do what you can, but the system is occasionally restarted and so on. So I wouldn't start any particularly long running jobs. Hope that answered the question Natasha had. Okay, all right.
Okay, excellent. Let's set up some breakout rooms now because we can